Last time I finished at the question number 4 onwards. Now we'll start question number 5. I'm going to ask the student how to do this problem. Integral 0 to pi by 2. 1 upon 5 plus 4 cos x. Tell me the method to integrate this. Tell me the method to integrate this. Mandar, what is the method to integrate this?
Put cos x in tan x by 2.
Put tan x by 2 as t. What is the next step?
Sir, we have a formula for like cos x to tan x by 2.
Okay, so cos x can be written as 1 minus tan square x by 2 upon 1 plus tan square x by 2. That is 1 minus t square upon 1 plus t square. Okay, next step.
Then make like take 1 plus tan square x by 2 to the numerator.
Okay, or we need to duplicate dx, no?
Yes, sir. So that 1 plus tan square x by 2 will become
You can do
sec
that. I'm
square
not saying
x
you're
by 2.
wrong, but better method is make x as a subject. Whenever we want to substitute t dx, make x as a subject and differentiate, because directly the derivative is not present. So this would be a little more better method. I don't say that what you said is wrong. What you said is also correct. This will be a little more better method. That means dx in terms of t, cos x in terms of t. Now you need to change the limit. When x takes value 0, what is t's value? Tan 0 by 2, which is 0. When x takes value pi by 2, t will be tan pi by 2 divided by 2. That is tan pi by 4, which is 1. So now what will happen? This integral will become 0 to 1. In place of dx, 2 dt upon 1 plus t square. In place of cos x, 1 minus t square upon 1 plus t square. So we have changed everything to t. So when you take LCM, 1 plus t square will get cancelled, but cancellation is possible only after LCM. Those who have practiced well, for them this will be just mentally calculation. And finally you get 0 to 1, 2 upon 5t square minus 4t square is t square plus 9. Now give me the answer for this. What is the formula for this integral?
1 by 3 tan inverse.
1 by 3 tan inverse t upon.
By 3.
And the limit is from where to where? 0 to 1. So final answer will be 2 by 3 into tan inverse of 1 by 3 minus tan inverse of 0, that is 0. So final answer is 2 by 3 tan inverse 1 by 3. Is this fine? Is this fine with you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now after question, are you writing or just looking at it?
Writing.
Completed?
Yes, sir.
Okay. Question number 7. Integral 0 to pi by 2 cos x upon 1 plus sin x into 2 plus sin x. I'll tell you who should answer me. Sarang? Sarang? Today I'm going to
Yes,
ask
yes.
everybody one question at least. You agree that this is a substitution method? And why? How do you come to know it's substitution or not? When can you do a substitution method, Sarang?
Sir, if we can see that its derivative is present in the numerator,
Correct. Whose derivative is present?
denominators.
Not all
So
the
we can-
denominator. We
Sir,
don't have
if
a whole denominator's derivative in the numerator. But what do you see? Which term's derivative is cos x?
sin x.
Sin x. So what is the substitution that you can do here?
So instead of sin x, we can
Replace it by t. So in place of sin x, we can put t because derivative of sin x is present.
is present.
That's the first point to remember. After you replace sin x by t, what is the method of integration? That also you have to look at it. After we replace sin x by t, what is the method of integration? Two methods are possible there. After you replace sin x by t, the function would be like this. Sin x became t. Sin x became t, and cos s dx became dt. Something like this would be.
Yes.
What is the method to integrate this? Today also I solve this.
Sir, this will become a square thing, like with degree 2, and then we can separate the coefficient divided by 2 and the square.
Complete the square. What do you call it? Open the bracket and complete the square. That is one method. Another method is you can do the partial fraction. You can split. This partial fraction method is taught to you, no?
No, sir.
Shagun?
No.
Huh?
No, sir. Partial fraction was not taught to us.
It was not done.
No.
5 types of partial fraction problems I have not completed with you.
No.
Okay. Then I'll have to teach. Then you should have told me this. Integration is not completed. Did I teach you this one? Integral e raised to x fx plus f dash x. This is done with you.
No.
This is also not done. Then what is the
No.
last video of integration?
So you taught us that I method.
Oh, this is also not done. That means the integration is not completed. Okay, anyhow. Then I'll do this by other method. Okay, then I have to, after this class, I'll start today's lecture. After this, I'll start that integration. Okay. So what I'm going to do here is put sin x as t. Then cos x dx equal to dt. When x is equal to 0, t is sin 0. When x is pi by 2, t is sin pi by 2. So this is 0, this is 1. So the limit is 0 to 1, 1 upon 1 plus t into 2 plus t. Now this is to be expanded. T square plus 3t plus 2. Now as Sarang said, complete the square. How to complete the square? 1 upon t square plus 3t plus 9 by 4 plus 2 minus 9 by 4. So integral 0 to 1, 1 upon t plus 3 by 2 the whole square minus 1 by 4. So from where did I get that 9 by 4? How you get that 9 by 4?
Divide the coefficient t by 2 and square it.
Divide the coefficient of t by 2 and square it. I think that is everybody knows. Okay, very good. Now this is of the formula integral 1 upon x square minus a square. 1 by 2a log of x minus a upon x plus a. So if you apply that formula, 1 by 2a, a became 1 by 2. A square is 1 by 4, so a is 1 by 2. Log of t plus 3 by 2 minus half, t plus 3 by 2 plus half. And the limit is from 0 to 1. Now they got cancelled here. Log of t plus 1 upon t plus 2. Limit is from 0 to 1. When you replace t by upper limit, log of 2 by 3. Replace t by lower limit, log of 1 by 2. Final answer is log of 4 by 3. Is it right? 4 by 3 is fine with you? Understood how 4 by 3 has come? 2 by 3 divided by 1 by 2. Is it fine?
Yes, sir.
Yes, sir.
Okay. Now we go for, are you right? Have you solved it or are you solving or not solving?
Solving.
Yes, sir.
Solving, sir.
Writing.
You have to be very sincere in this chapter, otherwise it's impossible to learn. It's so many methods, so many formula. If you don't make a real sincere effort in learning this chapter, it is not possible for you to do anything in this chapter. And there are 4 chapters depending on this. All 4 chapters are one after the other. Integration, definite integral, application of integration, differential equation. 4 chapters. That means almost 25% of the paper is in calculus. And this year, both in JEE main and also in advanced, integration was too many questions came. Integration and derivatives, calculus. So you have to put effort in learning this. Otherwise, it's not possible for you to get through all this. Completed?
Yes, sir.
Question number 9. Integral 0 to pi 1 upon 3 plus 2 sin x plus cos x dx. Zero to pi. Okay, so what is the method for this problem? Did we do today this problem before?
Yes.
Yes. Which method will you, what was the method we applied here?
Half and tan.
Put tan x by 2 st. Come on, start with me. Put tan x by 2 st. First, we'll replace dx, duplicate for dx. To get duplicate for dx, make x by 2 as a subject. So I can write x equal to 2 tan inverse t. Now if I differentiate with respect to t, I will get dx duplicate. So I can replace dx as 2 dt upon 1 plus t square. Actually, you don't have to write this many steps. You can directly write dx as 2 dt upon 1 plus dx square, provided you have enough practice. So the duplicates of dx in terms of t is done. Now sin x in terms of t. Tell me how to write sin x in terms of t. That means you need to write sin x in terms of tan x by 2. What will be your answer?
2t.
1 upon x.
Yes. 2 tan x by 2 on 1 plus tan square x by 2. This is also not required. Directly you can write 2t upon 1 plus t square. Not required to write this formula. I am writing this formula because if some student is not followed, you can follow it. Cos x will be replaced by this. So cos x will be replaced by 1 plus t square upon 1 plus t square. What more I have to do after this? Can I
Find k's value for limits.
Yeah, change the limit. We will say change the value of the limit. When x takes value 0, how much is t's value? Tan 0 by 2. When x takes value pi, what is t's value? Tan pi by 2. Tan pi by 2 is infinity. So your limit is 0 to infinity. So if I call this as I is equal to integral 0 to infinity. Dt became, 1 upon 3 plus 2 into 2t upon 1 plus t square. 1 minus t square upon 1 plus t square. And 2 dt upon 1 plus t square. If you take the LCM, 2 dt, when you take LCM, 3 into 1 plus t square plus 4t plus 1 minus t square. So calculate and tell me what will be the denominator. How many t squares are there?
2t square.
3t square, 2t square. How many t terms? 4t
4t.
plus 4. So we can cancel off the 2. Darshan, are you in the class?
Yes, sir.
You have to complete this square and tell me. How to complete the square?
Take the middle term, divide by 2 and square it.
So how can I write it as? T square plus 2t. Tell me what number should I add and subtract?
2, then subtract 1, add 1.
Add 1. So 2 here, can I write out like this? I subtracted 1 mentally.
Yes, sir.
Yeah. 0 to infinity. 1 upon t plus 1 the whole square plus 1. Now we'll have to tell me the last answer for it. So, Darshan, can you answer the formula for this last step? Do you remember the formula? Whose derivative is 1 upon x square plus 1? Or you can use this formula x square plus a square. Do you remember that formula? No. 1 by a is 1. 1 by a tan inverse x by a. This is a formula. A is 1 here. So tan inverse t plus 1 by 1. So by 1 I'm not writing. So that became tan inverse of infinity minus tan inverse of 0. So my answer is pi by 2. Tan inverse of 0 is 0. So final answer is pi by 2.
So tan inverse of 0 plus 1, it will be pi by 4.
Oh, tan inverse 1. Correct. Sorry. You are right. Tan inverse of 1 it will be. So it will be pi by 4. It will be pi by 2 minus pi by 4. So final answer will be pi by 4. I hope this is clear. Now I'm going to give you another question which came in the last examination. Last means 2 years back. Question number 11. Can I change?
Yes, sir.
Question number 11. Integral 0 to 1. Root of 1 minus x upon 1 plus x. Anybody? There are two methods to this problem. One of the method,
Rationalize.
Rationalize. Very good.
Rationalize.
Rationalize. What I'm going to do by rationalization. Can anybody tell me another method?
X
One
is
substitution
cos
method is
t.
Tan inverse x.
no. You can put excess cos theta. What is the benefit of putting excess cos theta?
The square terms we get in
Yeah.
cos and
Yeah, square root and square we can remove and then do it. That is one method, but I'm not using that method. I'll use rationalization method. So you can start with me. Rationalize the numerator. We should not have the root in the numerator. We can afford to have the root in the denominator. So rationalization, I mean, not the conjugate of denominator, conjugate of numerator. So that the root from the numerator goes off. But root in the denominator, we have formula, so we don't have to worry about it. Now, if you separate them into two parts, you know what is the whose derivative is this, you know. This is which one, whose derivative? And this what to do. This is a derivative of which term?
Sin
Sine.
inverse.
Sine inverse. And do anybody know this, how to do this integral? We have
take
done.
x as x square like in the derivative and then
Yeah, we have one direct formula here.
2 root x.
Integral f dash x upon f of x. Remember this formula?
2 root x.
Integral f dash x upon root of x. If the denominator's derivative is numerator, log of denominator is your answer. If the root is present here, 2 root fx is your answer. Is it right? Because if I differentiate log, 1 by u derivative of u. So naturally, 1 by u derivative of u means log of the denominator. Same way here, if you differentiate derivative of 2 root u, 1 by 2 root u into derivative of u. So same way that 2 will get cancelled. So 2 is 2 root fx. So what I do is, I'll divide and multiply with the minus 2. Now what happens? Derivative of 1 minus x square is present. So directly I can apply this formula. And here it will be sine inverse. So my answer became sine inverse of x from 0 to 1. And here directly I'll apply our answer. There is a plus half here. There is a plus half. F dash x upon root of x is 2 root of x from 0 to 1. Again, you will get this 2 cancelled. Now you can put the limit. Sine inverse of 1 minus sine inverse of 0 plus root of 1 minus 1 minus root of 1. Answer is pi by 2 minus 0 plus 0 minus 1. So final answer pi by 2 minus 1. Can see the screen now?
Yes, sir.
Now question number 13. Question number 13. Integral 0 to pi by 2. Sine 2x into tan inverse sin x dx. So what is the method here?
Sin x cos x.
What can you substitute here?
Sin 2x.
First of all, sin 2x should be written as Angles are different. Make the angles same. 2 sin x cos x. So angles are made same. Now whose derivative is present?
Sin x.
Sin x derivative is cos x. So you can put sin x as t. So you will put sin x equal to t. Because derivative of sin x is present. When x takes value 0, t takes value 0. When x takes value pi by 2, t takes value sin pi by 2. Yesterday, Deepak sir told me that he is going to start calculus. You people don't know anything in calculus. I don't know what you'll do. You'll do nothing there. You are going to say that you are not going to follow him because you have not yet learned the formula. Only those who learn the formula will be able to answer him. So I think you are too early to start integration. You can start derivative, but don't start integration. You have not yet learned. Without learning, you go and sit in that class, you'll get confused. You heard me, no?
Yes, sir.
So I feel you may application of derivative you can start, but don't start integration. Still, I make you expert on it. I have to give you an assignment. I understood today that you know nothing in integration. Can anybody tell me the method to integrate this?
I did.
Yesterday
I
homework it was there.
By parts.
By parts. So what is LIATE? So inverse is before algebraic. So this is a first function, this is a second function. This question was there in yesterday's homework. First function into integral of second. I am directly writing integral of second minus integral of derivative first into integral of second. I'm not wasting my time. Directly I've done the first operation. You can also do that. Now one good thing is all the 2's will get cancelled when you open the bracket. So I can write now this as t square tan inverse t. And to integrate this, majority of yesterday, some of you had asked me doubts. You could not integrate this. Degree is same. So the method is division. So add 1 and subtract 1. So you are indirectly dividing. So this became t square tan inverse t. Integral 1 upon 1 plus t square. One upon 1 plus t square. That became t square tan inverse t. Integral of 1t minus of minus plus tan inverse t 0 to 1 because this is a derivative of tan inverse t. Now replace all t by 1. 1 into tan inverse 1 minus 1 plus tan inverse 1. When you replace t by 0, this becomes 0, everything becomes 0. So this became pi by 4 minus 1 plus pi by 4. So pi by 4 2 times gives you pi by 2 minus 1. That is the answer. So you are, as I told you, with the Deepak sir, tell him to start derivatives and application of derivative. Don't start with the integration. Integration, what I'm going to do with you is, after I complete, you said 2 topics are behind. So I'll complete that 2 topics. Then I'll give you an assignment every day, 10 question. Around 15 days we'll do that. By the time you will learn all the methods. Then only, that is all the past question papers I'll make you solve from 1970 onwards. So once I do that, you will be thorough with integration. Okay. So I didn't know that I have not completed integration. I'll do one more question today. Then I'll start one of the integration exercise. Okay, which is left. Now I'm doing stuff 15, question number 14, because that it looks a little complicated. Integral 1 by root 2 to 1 e to the power cos inverse x into sin inverse x upon root of 1 minus x square into dx. Here, whose derivative is present?
Sin x, sin inverse x.
Sin inverse x derivative is present. But the problem is, when I put sin inverse x at t, what will you do with the cos inverse x? This can be t, the dt. Just analyze as I'll do. This will become t. This will become dt. But what about this one? This also
Pi
has
minus t, pi by 2 minus.
yes, very good. Cos inverse x can plus sin inverse x is pi by 2. So in place of cos inverse x, you must replace it by pi by 2 minus sin inverse x. Then only you can put sin inverse x as t. So that will be your first step. So you will be writing this as integral 1 by root 2 to 1 e to the power pi by 2 minus sin inverse x into sin inverse x upon root of 1 minus x square into dx. So put sin inverse x equal to t. 1 upon root 1 minus x square into dx is dt. When x takes value 1 by root 2, t takes value sin inverse 1 by root 2, which is pi by 4. When x takes value 1, t takes value pi by 2. I hope you understood that. When I put 1 here, you will get pi by 2. When I put 1 by root 2 here, I get pi by 4. So now I can write this integral as, so I is equal to pi by 4 to pi by 2 e to the power pi by 2 minus 1 minus t into t into dt. Again, we'll have to apply integration by parts. LIATE, which is the first function here?
T.
T will be the first function and exponential will be second function because E is last. I want one of you to tell me, I'll ask you, the student. Shreya Sharma. Shreya Sharma.
Yes,
How will I apply this formula? Just speak out. I should start with what?
first function t
First function. So I'll just write down the shortcut to remember.
plus t plus minus t.
Yeah, now apply that and tell me what should I write here?
T into integral of e raised to pi by 2 minus t
Minus t dt.
dt minus integral of derivative of first dt
Derivative
by
first. So I'll write directly 1. Because I'm not writing d by dt of t.
integral of second
So okay, I'll write integral of second. E raised to pi by 2 minus t
dt the whole dt.
Very good, excellent. That's what I was waiting for. Good, good, good. So t into, now integrate this. What will be the answer for this? So it is, what is integral of e raised to ax?
e raised to ax upon a.
So in that case, this will be e raised to,
Pi by 2 minus t upon pi by 2 minus t.
no, coefficient of t is -1. So this is a number. Suppose I write e raised to ax plus c, my answer would be e raised to ax plus c upon a. Only coefficient of x I have to divide. Here coefficient of t is -1, so you need to divide by -1. Minus integral of, now I am integrating this, e raised to pi by 2 minus t upon minus 1
minus 1.
into dt. Limit, of course, pi by 4 to pi by 2. So which I can write as minus t e raised to pi by 2 minus t. This will come plus,
Plus
but when you integrate this, again minus will come.
again minus e raised to pi by t minus t upon minus 1.
1. Yeah, pi by 4 to pi by 2. So it will be easy for us if I take common and then put the limit. So both of them are negative. So minus t plus 1 into e raised to pi by 2 minus t. Pi by 4 to pi by 2. So now I can write this as minus of, when I put the upper limit, pi by 2 plus 1. And e's power will become 0. When I put lower limit, pi by 4 plus 1. And e's power will become pi by 2 minus pi by 4, so pi by 4. When I open the bracket, this will be positive. So let me write the positive first. Pi by 4 plus 1 into e raised to pi by 4. And this will be negative. So minus pi by 2 plus 1. So I can leave my answer like this. So that will be the last question on definite integral substitution. But indefinite, I have 2 more small topics to be finished. So I'll start today with one of them. So I method was last done with you. I have to teach you a lot of things. Your book doesn't have all those things, right? Huh? In your class. Okay, can I close this?
Yes, sir.
Yeah.